I can click close, but it actually doesn't work. See, it's not really a window. It's just my monitor isn't refreshing. So that's a thing.
Sir, did you put out my review packet?
I did yesterday, yes, and I gave it to somebody else. You got to remind
Do we
me.
need a review packet?
That I will give you a review packet. Yes, I have a review
Shells.
packet.
Giant Yokers outside. He's working on it. Parking lot outside now. I don't believe in touching the floor.
That's the first time I fixed my legs. Rosie, what did you
Can we turn in our warm-ups today?
You can if you want to, yeah. I wouldn't. I just buckle up and get ready for this quiz review.
I want to write with this.
All right, we're about ready to be live. Let's pass these out. Where did I put these things? Big stack of them. Where'd my stack go? You're there. Wait, didn't I give you a review, guys? No, I didn't. I gave you the notes. Here's the review, guys.
It's a bag and a bag.
I'm allergic. Scabies. I'm only allergic to 3 things. My ex-wife.
Quiz number 4.
Why you have toilet paper on your
Sorry. No, it's fine. It's my bad. It's fine.
Lots of.
Plan is to have a test next week.
So we have a test tomorrow?
Nope, quiz is tomorrow.
Angry.
They're not the same. One's worth more than the other. No. All right. All right, I'm going to attempt to go live, but I'm guessing it won't, which means I'll just upload the video later. I've already uploaded the other classes, so if it doesn't upload for some reason, you'll have those to go off of. All right, so here's the deal. Let's close the door. All right, page 1 is all definitions and crap, so we're going to skip that for now. Page 2, it says, using only corresponding angles postulate, vertical angles theorem, linear pair theorem, definitions, and any of the properties of equality, complete the following proofs. Basically what this means is, okay, it's easier to say what not to use. You're not allowed to say that 3 and 6 are the same because of alternate interior angles theorem. You right, they is, but we're going to prove that, okay? So instead of me saying, prove the alternate interior angles theorem, I just gave you an example of alternate interior angles, and you need to prove that they're congruent, okay? That's all, okay? I guarantee after today, you guys will all feel better about this. Not all of you will feel better enough to actually ace this thing, but you all feel better, okay? That seems to be what happened in every single class, okay? So here we go. Angle 3 and angle 6 are what we're talking about for number 2, so I'm going to circle those in dark blue. There they are. So we are allowed to use cap, vertical angles, linear pair, and any definition. We probably won't need definitions. And substitution, because that's a property of equality, right? We're going to use subs. Like, that's like proofs in a nutshell. So 3 and 6. I'd like to be able to say, hey, look, they're equal. Bam, done. Here's my reason. But it's going to take a couple steps. They're on different parts of the different intersections, right? So we're going to have to link them together. We're going to prove them congruent. So we're probably not going to use linear pair, because linear pair says they're supplementary, right? So how can I bridge the gap between 3 and 6? Tell me something about angle 3. Tell me something about angle 3.
Vertical and angle 2.
That's true. Vertical with angle 2. So 3 and 2 are congruent. Let's write that down. And we know that by vertical angles theorem. That. I did forget the squiggly, right. They're equal. I felt something off. They're congruent. Figures are congruent. Numbers are equal. So 3 and 2 are the same dumb crap. Now, why is that useful? Because, like, I can say lots of things about 3. But why is 2 useful to help us to get to 6? Because they're corresponding, aren't they? Corresponding angles. Remember, what are corresponding angles? Well, if you look at the intersection, top right corner is going to be the same as the top right corner of the other intersection. But that's only true if the lines are parallel. So we forgot something. They give us the lines are parallel, don't they? So we should write that. Given L is parallel to M. Well, what's L and M? Well, that's what the lines are called. Duh, it says it on your paper just like it says it on mine. What's wrong with you? Call them L and M, or whatever you want, okay? Yes?
Are 3 and 6, would they be alternate interior?
They would be, yes. They are alternate interior. What we're doing is we're proving is that all alternate interior angles are congruent. Okay? We're just not allowed to use that theorem yet. We will next week. All right, so all of these, we're going to have to write that given L is congruent to M, or not congruent, parallel to M. I would write that right now. Free points tomorrow if you remember it. Free lost points if you don't. Nope, we're going to go back to it. Again, why do we need the lines to be parallel? Well, for vertical angles, we don't, right? Scissors theorem says any two angles that you create, no matter what, right, top and bottom are always going to be the same. But we do need this for cap. So check it out. If I have two lines that are not parallel, like so, definitely not parallel, right? And I draw a transversal that cuts them both. Again, these would intersect. I'm just not going to draw it because it would confuse you more. These two angles, 1 and 5, are corresponding. They're both in the top left corners of their intersections, right? Same relative position. However, we can't use cap because cap says if the lines are parallel, then you can say corresponding angles are congruent. They aren't. So they are corresponding angles, but they're not congruent corresponding angles because the lines aren't parallel. They can be corresponding. That's their name. They are corresponding, right? They are in the same relative location, top left, but they're not congruent. Remember, corresponding angles postulate says they are congruent if these are parallel, which they ain't. But for this, they are, which is why it's important we state it, right? So tell me that they're parallel. And then from here, we can use vertical angles. What do we know about 2 and 6? They are congruent by what? Cap, corresponding angles postulate, which says if they're corresponding and if these lines are parallel, then they are congruent. They are corresponding, they are parallel, right? So they're congruent. So I'm going to write angle 2 is congruent to angle 6. And I know that by cap, corresponding angles postulate, which would not be possible if the lines weren't parallel, but they is. Great. So now you'll notice that 2 and 6 are the same dumb crap, right? That's what congruent means.
So we can substitute them.
We can. We can switch the 6 for the 2. The old switcheroo. Substitution, right? So angle 3 is congruent to angle 2, but we can, instead of writing angle 2, we can write its twin brother, angle 6. By substitution. The swagger box.
That was amazing.
Oh, I love a cigarette. That kind of just.
So there we go. How you feel?
Great.
Dece?
Feels better than
Let's break it down. Let's break it down. Okay, angle 3 and angle 2 are congruent by vertical angles theorem. Vertical angles is the scissor theorem. See, 2 and 3, they're scissoring each other. Your words, not mine. Okay, vertical angles, they're congruent. I know that 2 and 6 are the same because they correspond. Top right corner, top right corner. So I wrote that. Corresponding angles. So if 3 is 2 and 2 is 6, isn't 3 6? That's substitution. How do you feel? Dece?
better than I did yesterday.
Dece? I'll take Dece. We only done one. So number 3. Angle 1 and angle 8 is what we're talking about. They want us to prove them congruent. Let's look at them. Angle 1. Angle 8. There they are. There they are. So we need to prove them congruent. You tell me your strategy. How are you going to get those two connected?
Hey, can you toss me a green? This is very
It's a 05. Let me give you an 07.
Alternate exterior.
Can't do that. We're not allowed to use those. We're allowed to use cap, vertical angles, or linear pair. Okay? If we next week we'll be able to use alternate exterior. They are alternate exterior, right? But right now we're proving that alternate exterior angles are always congruent. We can't just say, hey, they're alternate exterior, therefore they're congruent. Tell me something about angle 1. 1 and 5 are the same by cap, right? And what do I know about 5 and 8? Scissors, vertical angles theorem, right? So 1 is 5 by cap, 5 is 8 by vertical angles. Substitute, 1 is 8. That's the plan. Now I'm going to write that, okay? So going down here, angle 1 is congruent to angle 5. How do I know that? By corresponding angles postulate. Because they correspond. 1 and 5 are in the same dumb location, top left, top left. Meow. I know that angle 5 and angle 8 are also congruent. And I know that by vertical angles theorem, right? Because they are scissoring each other. Your words, not mine. 5 and 8, scissors. Yeah, so check it out. 5 is 8. They're the same dumb crap, which means I can take that 5 and switch it out for an 8, which is what I want to do, because I want to get 1 and 8 together. So 1 is congruent to 8 by substitution. Substitution. Le swag box. What color? How you feel? Feeling better? Good. I knew you would. Number 4! It says prove them supplementary. So we should probably say something about 4 and what it's supplementary to. So, all right, so 4 and 7. Okay, check it out. So 4 is supplementary to 2 other angles. 2 and 3. Now, which one would be most beneficial to get 4 and 7 together? 2 or 3? Yeah, but we can't use those yet. Can't use alternate exterior angles yet. Because we're proving it, right? We're proving it. Eventually, we'll be able to do the shortcut. 4 and 3 would be most useful. If I say 4 and 3 are supplementary, then I can say 3 and 7 are the same by cap, right?
Yes.
Do you see it now? Haley, see it now?
I have a question.
Yes, ma'am.
So is it going to be like this in a sense, like where it says like using only those?
Yeah.
This will be so much easier than I thought.
No, watch you get the test. You'll be like, what is this?
Yeah. I'm probably
Okay, so
gonna write my
4 and 3. What do we know about the relationship between 4 and 3? They are a linear pair. I had an epiphany this morning.
Why?
I've been telling you linear pair, and I'm saying, here's how you know what it means. Linear means on a line, pair means 2. 2 angles on a freaking line, right? But you guys, right? So, here's a new way to remember linear pair, okay? What is this?
It's a pair.
It's a pair! We have a winner. It's a pair. Now, what happens when I switch this pair down to a line? It still has a stem. What do we call that?
Worthless.
It's not a pair. It's a linear pair.
Oh, I see what you.
It's a linear pair. It's a pair that's been made into a line. And we have a linear pair, don't we? Angle 1 and angle 2 are a linear pair.
That's clever.
Yeah. Oh, yeah. Who amongst us has not thought of fruit while doing geometry?
I can raise my hand for that.
So, angle 3 and 4 are a linear pair. Here's the pair. There's the stem. They're a linear pair. They're on the same frickin' line. There's 2 of them. Okay? So, 3 and 4 are a linear pair. What does linear pair theorem say? If they're a linear pair, then they are supplementary. What does supplementary mean by definition? 180. So, we're going to cut to the chase. Unlike last week where we have to say, they're a linear pair by definition. Therefore, linear pair theorem says they're supplementary, right? We're just going to say 3 and 4 are supplementary by linear pair theorem. Yeah.
That makes me upset.
Yeah, it is. So angle 4 and angle 3, that's geometry, guys. As we go further on, we take more shortcuts, right? 4 and 3 are supplementary, is what we want to write. Supplementary. I'll write it all out. By LPT, right? Linear pair theorem says they're supplementary. Not that they add up to 180. Okay? That's by the definition of supplementary, right? That's what supplementary means. So we know 4 and 3 are supplementary. Great, wonderful, excellent. Who cares? Why did we do that? Because 3 and 7 are the same dumb crap because they are cap. So angle 3 is congruent to angle 7. And we know that by corresponding angles postulate. Again, wouldn't be possible if they weren't parallel. That's why we have to state that. Now check it out. 3 and 7 are the same dumb crap, which means we can switch out 7 for 3. Now, when we do this, don't write 4 is congruent to 7, because they ain't. It says 4 and 7 are supplementary, right? So write that. I guarantee someone's going to put a congruency sign here. 4 and, instead of writing 3, I'm going to write angle 7, right? Because they're the same dumb crap. They are sup.
And that's by.
Yeah, by substitution. We switched them out, right? Substitution. And we're done. Swag box. Christmas colors.
No, it's October.
But there's also purple.
Yes. You're right.
Don't make it. Don't get her started.
I got it. All right.
5.
Number 5. It says 2 and 8 are supplementary.
Blue.
2, 8. Tell me your strategy.
28.
2 and 8.
Fine.
All right, 2 and 6 are corresponding. Okay?
Okay, two and
And 6 and 8 are supplementary.
yes.
So we can switch them out. So here's what I would do. I would say 2 and 4 are supplementary. 4 and 8 are the same thing, switch them out, right? That's what we did last time. But you could do it reverse. You could say 2 and 6 are corresponding. 6 and 8 are supplementary. Switch out 6 for 2. You do you. You do you. You do you. So I'm going to do it the way I did it last time. I'm going to say 2 and 6 are corresponding, okay? Which means they're congruent. So, yep. 2 is congruent to 6 by corresponding angles postulate. I know that 6 and 8 are a linear pair, right? So I'm going to write that. Angle 6 and angle 8. They're not supplement, or they're not congruent. They're supplementary. Are supple. They are supple by linear pair theorem. Right? Because that's what a linear pair is. They supplementary. And now we're going to switch out the 6 for the 8.
But don't we need to speak to more supplementary?
That's another way to do it. Hold that thought, and I'll do it your way. Okay? So I know that angle 2 and angle 8. Oh, wait. Whoops. I did this backwards. Pause. Buffering. Buffering. Okay. 2 and 6 are the same thing. So I'm switching 6 for 2. Right? Instead of writing 6 and 8 are supplementary, I'm going to write 2 and 8 are supplementary. And that's by substitution. Done. Haley, this is how you wanted to do it.
Well, I was like, how would that look like? Only 6 and 8.
2 and 6 are the same thing. 6 and 8 are supplementary. So instead of writing 6 and 8 are supplementary, I can write 2 and 8 are supplementary.
So we automatically know that 2 and 4 is
I'm sorry, what?
So we automatically know that 2 and 4 is supplementary now?
We don't need 2 and 4 for this one. Let me go back to the diagram. So the way we did it, okay, you did it differently. The way we did it was we said 2 and 6 by cap, 6 and 8 are sub. So I switch out the 2 for the 6. Right? You said 2 and 4 are sub. 4 is the same thing as 8. Switch out the 8 for the 4. It's all good. I like both. Questions? Do you feel better? Feel okay?
Yeah, but then when the test hits, we're gonna put.
Yep.
Well, it's kind of repetitive. Open note quiz.
No, dear God. Why would I quiz you over your notes? I write your notes. I know it. Okay? That's why I'm able to make the notes. Buckets. All right. Did I not? I got the gap? I shot the gap. Triple bozo bucket. All right. So, it tells you that AFB and EFD are 65. This should look really frickin' familiar. Okay? I'm using frickin' a lot today. These angles are all 65. So that's going to be this guy and this guy. I changed it from 55, girlfriend's age, to 65.
What'd you just say?
It's a video online, 55. Look it up. All right, 65. They tell you that points BFD and EFC, you know what BFD stands for, are collinear, which means they are lines. So your eyes do not deceive you. I'm going to give you a different diagram tomorrow than this. I am. It's going to be different, okay? You might look at this and be like, I don't know if that's a line or not. Well, they tell you it is, okay? AFD, I assume you can tell it's not. Help yourself. State whether each pair of angles that's given here are vertical, linear pair, or neither. Sound familiar?
Yes.
Wonderful. No yawning in math class. BFC, that's this angle right here. And DFE, this angle right here. These two. Are they a linear pair? No! What are they? Scissor. Vertical angles, right? Vertical. Vertical. A-L. Which means, by vertical angles theorem, they are congruent. So I'm going to do them both in pink. 65, 65. BFA and DFE. BFA, that's the degree people that can't handle a real music degree get, Bachelor of Fine Arts. DFE, down here, okay? They're both the same. They're congruent. That's wonderful. It's great. But are they vertical? No. No, that ain't scissors. Are they a linear pair?
No.
No, right? Because there's an angle in between them, right? This is not a linear pair. That's not what pairs look like.
has two stems.
They're collinear. All three angles are collinear, but they ain't a linear pair. Linear pairs look like this.
So they
That's a great question. Cherries.
They're neither.
Neither.
No, cherry only has one stem.
No, it's two stems. They come in pairs. That's the joke. All right, so neither. BFC and CFD. BFC, CFD. Linear pair. Two angles on a line. They're on line BFD. So they're a linear pair. Now, what do we know by linear pair theorem? They must be supplementary. Ah, beautiful. I love how you corrected that. Which means, by definition, they add up to 180. So that's 65. How much is left over for our blue angle right here?
65 plus 65.
No. They add up to 180. 115. I love how we all feel comfortable in here. That's good.
Why is that 115 again?
Because they're a linear pair, because they all sit in a line.
Yeah.
So they should add up to 180. 115 and 65 makes 180. Okay? 110 and 60 makes 170, and then 5 and 5 makes the extra 10. AFE. This guy right here. Let's do it in orange. Okay? And AFC, like the football conference. But let's do that in perps. Right? So these two angles, the big purple angle and the the orange angle, what are they? Linear pair. They are. Even though there's a divider in the middle, it's okay. We're talking about that whole thing plus this thing, right? They're a linear pair. Those two angles make up the entire line. Okay?
So we're treating it
So we know that, yeah, as if it's all one thing, right? Because it is all one thing. Now, by angle addition postulate, we know that we are allowed to add up the two little angles to get us the big angle, right? So the two pink angles are going to add up to the purple angle. What is that? What's 60 and 60? 120. What's 5 and 5? 130. You can do math in your head. Just break it apart differently. That's how people that do math in their head do it fastly, quickly. I tried for the adverb. Quickly. It's not because they just have everything memorized. Break it apart. Think creatively. All right, so this is 130. We know they're a linear pair. So by linear pair theorem, they are supplementary. By definition, they must add up to 180. So how much is left over? 50. Right? Because that's 130. 50 more. So they're a linear pair. AFE and AFC. Brundaba. All right. BFE and CFD are the next one. So let's find BFE. BFE. Ooh, it appears to be this one. What color shall we use now? How about green? That guy right there. And then the blue angle is CFD. They're vertical, right? Ignore this. They're still scissors, right? Scissors. The left side and the right side are going to be congruent. So they're vertical. Vertical. And we know that if they're vertical, by vertical angles theorem, they're congruent, right? So if this guy's 115, how much is the green going to be? 115. Let's check to make sure we haven't screwed anything up. 65 and 50, by angles addition postulate, should add up to 115. Do they? 65 and 50. 60 and 50 is 110, right? 5 more is 115. Checks out. AFE and BFC. AFE, that's the orange angle. BFC is this angle right here. Are they vertical angles? Well, they better not be. They're not congruent, right? Are they a linear pair? No. There's a guy in the middle. So they're neither. Neither.
Wait, so it's
Who likes some soda and
if A's not there, they
Nope. Well, if A isn't there, then we wouldn't be able to say angle AFE, right? See what I'm saying? All right, it says find angle AFE, DFC, and BFC. We already did. They're up there. Write them down. Moving on.
Wait, what's 11?
Neither.
Oh, poop, I did not pay attention to number 10.
Okay, so we've done the first 2 pages, or the last 2 pages. Let's do the first page. Definition. All right, transversal. Maroon, chartreuse, crimson, burgundy?
Aquamarine.
That is not what this is.
Someone's colorblind.
Are you someone's colorblind?
I thought you were naming colors that you wanted us to pay.
No.
We don't have aquamarine, so that's not.
I don't know what this color is.
That is.
Maroon, chartreuse, burgundy, crimson?
That's not.
I like chartreuse.
first page, right?
If I make this from the back corner of the room, can I get an A?
ASA, I am bones. Go for it.
Justice, you remember Mr. Bones?
You're not gonna do
What?
it. I called it.
Mr. Bones, no leg, goose,
If I win this
You
match,
might want to
I
watch
get
out.
candy.
Bro, I'm hitting the deck. I am not getting shot.
You're gonna hate Kayla.
Wow,
Wait,
just
I
like
was
great.
light, okay? Wait, I wanna try. Let me try. No.
Wait, we get an A if we make it in the garbage?
Let me try.
I hate that.
It went outside. Or-
It did go outside. To the outside.
I mean,
All right. So transversal sounds like a wrestling move, but it ain't. Tell me what a transversal is.
There's a line that goes.
It's a what? It's a what? It's a line.
a line that goes parallel.
Oh, did you chill out? And then
That what?
Wait, isn't that?
Wasn't that you making fun of Macy this morning?
Cuts
Did I just say
two other lines.
That are broken.
Yo, what's up?
our parents?
horrible shot.
Why'd you say
Come back soon, okay?
I'm sorry, I'm not in it too much.
Cuts two other lines. Do the lines have to be parallel?
Yes.
No.
Yes.
It's only the magic happens when they're parallel, but they don't have to be. Okay. I know. Well, the magic happens, right? It allows us to use cap and all the other stuff, right?
What we just did.
Yeah.
Where's the baby?
What?
You said the magic happens. Where's the baby?
Oh my, just shut up.
Wow. It is the funniest thing Justice has said thus this year. Okay?
Of course.
Doesn't mean it's funny, but it is the funniest, right? All right, corresponding angles. Oh, first of all, what's the example of a transversal in our diagram? T. So you can either write cursive T, right, because that implies a line, or you can do line T. Doesn't matter to me. Okay. Corresponding angles are angles, right? Angles that don't say correspond, right? Define what correspond means. They are in the same relative position. Remember, not in the same. That'd be the abomination. You write that, I'm going to have to draw the monster on your test. Angles that are in the... I know. I promise things and then I don't follow through. I'm like a stepdad. Angles that are in the same relative. Moment of silence for those of you that have stepdads that do that.
My stepdad beats me. I wish I had a stepdad because that'd be dad. I don't have either.
My stepdad's an
Gary, you have Gary.
My stepdad's an alcoholic.
Gary is like.
All right, corresponding angles. Give me an example of two of them. Don't say 1 and 5. 2 and 7. 2 and 6. 2 and 8. 2 and 8. Corresponding, same relative location.
4 and 8.
Top right, top right. 2 and 6.
2 and 6.
4 and 8.
No. Okay, you're correct.
4 and 8 work. Careful how you say it. 4 and 8. Same side interior angles. Oh, by the way, I forgot. I list alternate exterior angles up here, but I forgot to include same side
No. Okay.
exterior. I've told everybody except first hour that. Good luck, first hour.
We're gonna get the test today.
What? That wasn't on there. What was on the homework?
So, yeah.
It's the third time you've seen it. All right. We need, and we did it in class. Corresponding angles. We've done that. So same side interior.
Same side.
Okay, I'm going to write in different colors. Same side interior angles are angles that are what? What's same side mean? On the same side of what?
Transversal.
Yep. The transversal. Well, we have 3 lines. Be specific. That are on the same side of the transversal, whatever it may be called. I usually call it T, but that's just me. We're going to have more than one transversal eventually. Side of the transversal. And in the interior of the what? Of the... Well, they're not always parallel. See, that's the thing. Interior of the intersected lines.
In order for them to be like that, wouldn't they have to be corresponding angles? No.
Same side interior? No, that'd be like 4 and 5. They don't correspond. 4 and 8 correspond. Can't really say that one. Sorry, Autumn. In between the intersected lines. Which lines are intersected? P and Q are intersected in this diagram, right?
Yes.
Cool? Awesome. Next one. We did same side interior. What's the other interiors?
Exterior.
We did same side interior. What's the other one? Same side exterior. I'm going to jump to alternate interior. I'm going to do alternate interior next. Alternate interior angles are angles that what? Alternate
We're on the opposite side.
on opposite sides.
Go, Rosie.
Rosie's on fire
This is what I do.
of the transversal. And are in the interior, right? Be specific. Interior of what? Interior of the intersected lines. Go. Now, I'm not going to write down alternate exterior. I'm not going to write down same side exterior because it's the same dumb crap, except they're on the exterior, which means they're on the outside. Same dumb crap? Yes, you can. Same dumb crap, except they're on the outside of the intersected lines.
Hey, don't do that.
So same dumb crap as these guys, they're just exterior, right? So you would say on the outside of the intersected lines. How you feel about that?
Okay, honestly, I feel
Well,
okay.
the thing
I told you.
that mess up is the writing.
I told you. I'm not doing matching, okay? That's not how I do definitions. You're going to write this, okay? Am I going to include all these? Probably not, so you really need to know your crap, okay? You really do. Oh, we forgot to give examples. Let's give examples of same-side interior angles. Angle 4 and angle 5 would be same side. So angle 4 and angle 5. Don't forget your examples. What about alternate interior?
1.
Alternate interior. 4 and 6. Now, why are 4 and 3 not examples of alternate interior? They're in the interior. They're alternate. They're across from each other, which means they're actually a linear pair. Right? So we're going to call them a linear pair. I like how you guys think about that and how you guys were like, wait a minute, wouldn't that fit the definition? That was clever. I don't think most people think about that when they teach this stuff, which means you guys are really wondering, what does it mean? Which really is the only question, right?
Is there going to be like on the mornings that you tell which ones are congruent and nostalgic?
I mean, I kind of get that out of this, right? And I kind of get it out of this.
So that's a no.
And that's a no. So,
Oh crap! I have to serve detention tomorrow morning.
crap baskets.
I've been late to Howard's for the past week.
No.
Why is it Andrew?
Getting detention from Mr. Mack.
He didn't get it. Well, I mean, he did, but he didn't. I had mercy upon your soul. Really, Bechtel did, actually.
Are we done writing?
That's it.
We didn't do AEA.
AEA. Oh, we didn't, but remember, I'm saying I'm not going to write it. It's the same dumb crap as alternate interior, but it's just outside the intersected lines, right?
Did we really just finish early in this class? No.
In the first time.
My class is so hard. Oh, no.
Yeah, but we normally like go over the bell.
Oh.
No bueno. No, he's going to go get it. All right, so that's the deal.
What?
Knock this out of the park tomorrow. This is not easy. You need to go home and actually study. You know how I know you didn't study? When you bomb all the definitions. Right? Because literally that's just know them and you're fine. How do you know them? You study them so you know what they are. Okay? These proofs you could really memorize as well, but guess what? I'm probably going to throw a curveball tomorrow to make sure you can't memorize them. You need to know what you're actually talking about, okay? Like, I could switch up the numbers very easily, right? And I could make the diagram sideways. You have to actually know what you're doing. Oh, I will. Oh, I will, okay? Knock this out of the park. Same thing here. Are you going to get the same diagram for this? Oh, dear God, no, right? I was lazy and just threw this together last night. I'm going to make one special just for you guys, okay? I know. You need to know your actual crap. That's why I give the exam. If I didn't need to know that, then I wouldn't give the exam, and we just wouldn't do it at all, right? And then it'd be like, well, why am I teaching this? Because I'm not really teaching. And we just cancel the whole class. We all go home, right? If I have to be here, we're going to have to learn something. That's my one rule.
At least we can
So do
set
you want
up
to
the
print my,
What?
do you want to print my thing?
I do. Yes, I really, really do.
Except Autumn, because
All right. Quiz review for number 3.
Yeah. No, yeah.
Is it the quiz 3, the most recent one, the proof?
Yeah.
Who's here for Howard?
Tony Chestnut.
Wait, we're doing those.
Stop.
You found that one too?
Of course.
That's not
They're all a bunch of dinguses.
I felt mine by like 2%.
So, can I have a pass for Hobart?
Yep, all right, passes. Who wants to pass to my homeroom, which will have like 300 people? Oh, good God.
Can I go
Dude,
get
I
that?
don't have any other time. I am a, like, I have stuff.
David is sending me a form for Justice. I didn't go to the office.
Justice, where do you get your haters?
Shoe sensation over in Sterling Mall.
Dude, who gets stooge from Shoe Sensation?
All right, you need a pass. Who else needs a pass?
I need
For
to,
what?
take
Yeah. Are you able to?
One pass.
Yeah.
Alright, we're not singing Tony Chestnut. I'm done.
Maybe able to pass it.
I should have
No, you
We'll try. I try our best.
Please don't waste my time. No one has to grade it if you're not going to pass.
I have to take it regardless.
Rosie, you pass.
I have to take it regardless.
Getting past it.
Gentlemen, sit down. Guys, get back in here.
I gotta get past it.
I need a pass.
Where are you going
Dear God.
I need a pass.
Okay, sit down, raise your hand, and I'll get to you. All
Tony
right, David, you need a pass? Raise your hand.
All right.
I mean, it is always easier not to come to homeroom than to do it after school.
Bruh, I hate it.
Kobe.
I can't do it after
Justice,
school.
Justice,
What?
Kobe, Kobe.
Give them all.
I would start in homeroom and then you get out of here early. You need one?
Yeah.
Tana, I didn't know you were a guy.
Did we review it already? Did we review that test together? No, we haven't reviewed it then, man. You can't take it today.
Obi!
Alright.
Robert, whose pencil is this? Whose pen is this?
Read it.
But she said the front or the back?
Oh my god.
Give me that back after it's turned on.
I want you, and you can do it or not. I'm not gonna make it. Put that in there.
Oh, I hit him again.
Schlauber, hit me with that alley. Hit me up with the alley. You suck.
Paul Zipson.
Hit me up with the alley. Hit
She's into that stuff, I keep telling you.
me up with the alley.
That's it.
Right here, right now. You gotta do this right here, right
I
now.
was singing to her.
I don't.
I was so like,
What language here? What?
I haven't reviewed it yet, and I haven't got my thing signed.
If you get it signed before tomorrow and you review with me today. I review with you at the end of the day. Yes. Yes, ma'am.
What time are
360. It wasn't
So
enough.
I just say, so it's
It equals 360. Yeah.
I don't know what
You may not Taylor Swift. Yes. It's a
That costs like $5,000. Way to spend all my groceries.
You're walking to school, you like you did.
Wait, scroll up. Oh, I thought that was Schlauber.
Hey, is my paper gonna be in the teacher's lounge or
Look at the date of the picture.
Because I ate lunch, you idiot. Yeah, I play the piano while I'm waiting for them. Want to hear it? Yeah, what do you think this is? Parking here? Don't wash my face. I like, oh shoot.